it has been already introduced in previous modules how composite materials are often exploited in large infrastructures. To be correctly recycled, composite components must undergo a sequence of processes for their isolation and volume reduction to fit recycling equipment dimensions. The main steps and principles of large end-of-life composite infrastructures dismantling are explained in this video via the example of the dismantling of a wind blade from its turbine. The same main concepts of disassembly and in-situ size reduction apply also to other products, such as boat vessels, aircrafts, and construction elements. The recycling-oriented dismantling of wind blades has challenging boundaries. It starts with an object of potentially more than 50 meters and 10 tons hanging from a tower, typically in natural hilly environment, and it ends with composite sections, usually smaller than 1 square meter. The first indispensable task is the removal of the blade from the tower, made by skilled operators which use specific cranes and equipment. After the blade is secured to the ground, the dismantling chain arrives at a crossroads. It's either possible to set up an outsized load for the transportation of the full blade to the recycling plant, or to arrange an in-situ size reduction of the blade, at least to fit standard containers dimension. The first possibility embeds the difficulty to arrange outside loads, with the related bureaucracy, technical complexity and costs. The second possibility, the most exploited, must consider that composite structures size reduction is a very pulverulent process. The cutting zone, where shears and blade often loaded on bulldozers operate, must be prepared with ground-protecting cloths, water hoses and cannon fogs to capture the generated dust. 6 to 8 meters sections of the blade are often produced to minimize the number of cuts to be done on site. Even considering size reduction, the three-dimensionality and hollowness of blade shells and cores forces the arrangement of very unsaturated containers and transports. The recycling-oriented dismantling of composite infrastructures ends at the recycling plant, where blade sections are furtherly cut, with particular focus on the segregation of non-composite parts as metallic and balsa inclusions. To conclude, it's now clear that the preparation for recycling of a large composite infrastructure is a non-trivial process, whose costs reflect on the overall sustainability of the end-of-life management of these products.